Chapter 5 is about sequences and series. Um, to give an example of a famous sequence and series, the book introduces a story where the inventor of chess was given the opportunity to say what reward he wanted from the king in exchange for making the game of chess. And he said that he would take the chessboard and he would ask the king for grains um, to fill up the squares of the chessboard. In the first square of the chessboard, he wanted 1 grain. In the second square of the chessboard, he would like 2 grains. Third square, he would like 4 grains, and so on. So you can already see the pattern, right? So in the first square, he would like 1 grain. In the second square, he would like 2 grains, and in the third square, not 3 grains, but 4 grains. So this is not 1, 2, 3, 4, 5. He appears to be doubling the number every square. Okay, and so write a math expression to calculate the grains of wheat in the last square of the chessboard. Okay, well, we can see that in the first square of the chessboard, it's just a 1. In the second square of the chessboard, it would be the first square times 2. In the third square, it would be the second square times 2. You could also write the third square as if it was the first square doubled twice. So we could say that the 4 is calculated by doing 2 times 2. And so the fourth square would be, which would be 8, would be 2 times 2 times 2. So we can see that the pattern appears to be first square 2 to the 0, second square 2 to the first, third square 2 squared, fourth square 2 to the third. So it always appears to be 1 less than the position of the square. So if we wanted to figure out how many grains are on the last square of the chessboard, then we should first find out how many squares there are in a chessboard. Just to give you a hint, a chessboard is 8 squares across, and it's a square. So it's 8 by 8. How many squares in an 8 by 8 chessboard? It would be 64. So we would put something like 2 to the 64th, but we wouldn't put 2 to the 64th because we will always subtract 1 off the position of the square. So we would do 2 to the 64 minus 1, which would be 2 to the 63rd. We won't calculate that here because, as the story says, that's more than there are grains of rice in the world. So we'll just leave it at that. That is the math expression to calculate the answer, although it's quite hard to write out the answer. A sequence is an blank list of blank defined by a blank. It's a list of numbers, right? A sequence is a list of numbers. Here, if you look in the book, they talk about it being an ordered list of numbers. Okay, it's in a specific order, usually increasing or decreasing, depends on the rule. Okay, and that's getting to this here, defined by a math rule. Okay, so if you look in the book on page 152, that's their definition of a sequence. An ordered list of numbers defined by a math rule. Each number is called the member or element. Term of a sequence. Term of a sequence. Element would be a set. It's a term. Normally we call it term. A sequence which continues forever is an infinite sequence. That makes sense, right? We use punctuation to show that it continues forever. What punctuation do we normally show that a sequence continues forever? If we have the sequence 1, 2, 3, comma, something, what do we put here to show that it goes on forever? Usually period, period, period. Write an example of this kind of sequence. Well, we could just put that. We could put 1, comma 2, comma 3, comma, period, period, period. That's an infinite sequence. By the way, what's the math rule for this sequence? Well, it's just, add 1 each time. A sequence which terminates is a finite sequence. It's just the opposite of an infinite sequence, so that makes sense, right? A finite sequence. Write an example of this kind of sequence. Well, we could just write 1, 2, 3 and not put any punctuation after it. That indicates that the last number in the sequence is 3. Write down the first 4 terms of the sequence if you start with 4, and they're giving us the math rules here, and all we're doing is using the math rule to figure out what the first 4 numbers are in the sequence. So the first number is 4, they're giving it to us. To get the second number, we do 4 plus 9, we get 13. Then we add 9 again, and then we get the next number, which is 21. Then we add 9 again, and we get the next number, which is 30. So these are pretty easy, right? First number is 45. We're going to subtract 6 every time. Oh, they're getting tricky here. They're doing subtraction instead of addition. We can do that, though. We don't even need the calculator. 27. Okay. Now, next one. 2 and multiply by 3 each time. So do you see that, like, the only common thing here is that we're always using the math rule to figure out what the next term is. Not necessarily multiplication, not necessarily division, not necessarily addition, and not necessarily subtraction. Now I'm going to have to use a calculator to do this one. 54. Okay. 96 divided by 2 each time. So 96 divided by 2 is 48. 48 divided by 2 is 24. 24 divided by 2 is 12. Okay? Alright, moving on. For each of the following, write a description of the sequence and find the next 2 terms. So if we have 8, 16, 24, 32, let's see, it looks like addition, and it looks like they're adding the same number to every time, which appears to be 8, right? So if we wanted to find the next 2 terms, we would put 32 plus 8, which is 40, and we would put 40 plus 8, which is 48. Let's see, what about for E? This appears to be, doesn't appear to be addition, right? Because the jumps are not the same each time. So the first one they're adding 3, next one they're adding 8. So that is not, doesn't appear to be the right math rule. What about like multiplication? Is there multiplication they could be doing here? 1 times 4 would be 4. 4 times 4 would be 16. 16 times 4 is 64. So it appears to be multiplication by 4 is the rule. And the next number would be 64 times 4. I think it's like 256. 256. And then 256 times 4 would be 1024. Okay. What about C? Let's see, looks like it's decreasing every step, and the first time it's decreasing by 5, next time it's decreasing by 5, next time it's decreasing by 5. Looks like we found the rule, it's minus 5. So the next one would be like 16, and the next one after that would be 11. Okay, what about G? Looks like we're dividing by 2 every time, right? Dividing by 2? Yeah, it looks like we're dividing by 2. Okay, so that would be G. It's pretty easy to find the next 2 steps. And what about I? Let's see, we're dividing by, looks like we're dividing by 5 every time. Okay, so that'll get you started on those. Next one, describe the following number patterns and write down the next 3 terms. Okay, now these are a little bit trickier because 1, 4, 9, 16, that's not multiplying or dividing by a set number. If you look at it, there's something common between these numbers. They're all squares. And if you think about it, these are squaring the ordinal numbers. So like 1, 2, 3, 4, 5, it's squaring each of those, okay? So the next 3 terms would be 5 squared, which is 25, 6 squared, which was 36, and 7 squared, which is 49. Okay, and then Now why don't you pause the video and see if you can get C by yourself. Okay, now I assume you've thought about it for a little while. This is actually related to this one here. So if you take 1, 4, 9, 16, and you add the ordinal numbers to this, 1, 2, 3, 4, you're going to get the result here, which is 2, 6, 12, and 20. Okay, so the next couple numbers would be, let's see, 25 and 36 here. Will be plus 5 and plus 6. So that would be 42, and this would be 30. Okay, a little tricky. Find the next two terms of, so this one looks like it's simply subtracting 4, so just find the next two terms using that rule. This one here looks like they're adding, they add 2 here, they add 3 to the next one, they add 4 to the next one. So to get the next one, they're going to add 5, which would be 16, and then the next one they're going to add 6 to get like 22. Okay. What about this one? 1, 16, 81, 256. Those look like squares, but they're not all the squares. We got 1 squared. Oh, let's see. No, actually, I think I know what they're doing. It's, what would that be? 2 to the 4th, 3 to the 4th, 4 to the 4th. So these are all powers of 4. Okay, so the next ones would be 5 to the 4th and 6 to the 4th. You could use your calculator to help you find those. Okay. Now we're also going to be doing section B because A was quite short. Write 4 possible ways of defining a sequence. You'll be able to find 4 ways of defining a sequence, and these aren't all the possible ways, but these are the ways that are found on page 153. One is you can like write out all the terms if it's not an infinite sequence, of course. 2, you can list the first few terms and assume that the pattern continues indefinitely, like something like you could write, 1, 2, 3, comma, dot, dot, dot. Description in words, you could write something like the even numbers starting from the number 2. That would be describing 1 in words. Formula, which represents the general term or the nth term, you could say something like x sub n is equal to n times 2. Okay, something like that. Okay, and we're going to be working on that method for this section. The general term of sequence is also called the nth term. N is what they call an index. It is a number which tells you the position of the term inside the sequence. It can be represented by a symbol like the general term can be represented by a symbol like U, capital T, small t, or A with a subscript n, such as, and then we can write something like A sub n, something like that. N is a number from the number set z plus. What kind of numbers are in z plus? Well, z is the set of integers. Positive just means the positive integers, so we'll write that it's the positive integers. For the general term defined by 2n plus 1, where 1 is the smallest value of n, write the first 5 terms. Okay, so we're going to, the first term would be 1 times 2 plus 1, which would be 3. So the first term would be 3. The second term would be 2 times 2 plus 1, which would be 5. Third term would be 3 times 2 plus 1 is 7. And now you can already kind of guess what the other numbers are going to be, right? Okay. A sequence is defined by un equals 3n minus 2. Okay, so now it's just saying, okay, well, what is the first term? What is the 27th term? Well, they gave us a formula for it, so the only trick is, what do I put in for n? Well, look at the notation here where I write a sub n. It would be like u sub n. So if I write u subscript 1, what do you think n is? Well, n is 1, right? What if I write u27? What does that mean? Well, n equals 27. Okay, so u sub 1 would be, all we need to do is write, in this case, it would be 3 times 1 minus 2. So that would be 1. And then U27 would be 3 times 27 minus 2, which would be about uh, 81, I think. 81 minus 2, which is 79. Okay, here we are on number 2. Consider the sequence defined by un equals 2n plus 5. Find the first 4 terms of this sequence. Okay, so the first term would be when n equals 1, u1 equals 2 plus 5, 7. u2 would equal 2 times 2 plus 5, which is 9. u3 would equal 11. u4 would be, now we can already see the pattern, right? So we're going to have 7, 9, 11, 13. It says display these numbers on a graph. Well, so let's say if this is 1, 2, 3, 4, then we're putting 7, 1, 2, 3, 4, 5, 6, 7, 9, 11. So 1 would be 5, n equals 2 would be 7, n equals 3 would be 9, n equals 4 would be 11. So that's how you would graph that. Okay? Evaluate the first 5 terms of the sequence. So for 2n, I would put n equals 1 would give you 2, n equals 2 would give you 4, and then we can kind of see the pattern, right? And then C would be, it would be 1, 3, 5, 7, 9, you see? And then E would be 5, 7, 9, 11, and this would be, can't read my writing here, it would be 13, right? G would be 3 plus 1 is 4, 6 plus 1 is 7, 9 plus 1 is 10. Now we can kind of see the pattern, right? Okay. Evaluate the first 5 terms of the sequence. So let's see, 2 to the n, that would be, 2 to the first would be 2, 2 to the second would be 4, 2 to the third would be 8, 2 to the fourth would be 16, and now we can kind of see the pattern, right? C. So the first one would be 6 times 1/2 to the first, that would be 3. The second one would be 6 times 1/2 to the second, that would be 6 divided by 4. And then the next one would be 6 divided by 8, and 6 divided by 16, and 6 divided by 32. Okay, evaluate the first 5 terms of the sequence, 15 minus negative 2 to the nth. And they want you to do this with technology. So how do you do this with technology? Well, first you go to the stat page in the calculator, you stat edit, and then you go and you make a column of numbers which is going to represent your n values. So you're going to have 1, 2, 3, 4, 5. 3, 4, 5. And then in the second column, you're going to enter the formula to find what you're looking for here. So we're going to put 15 minus, 15 minus, and then in parentheses we're going to put negative 2, where's negative? Negative 2 to the nth. And the nth would be L1, right? Because we put those values into L1. And that's it, right? Okay, let's try that. Okay, and then it calculated all the values already here. So the answers are going to be 17, 11, 23, negative 1, and 47. Okay, and that might have been time consuming to calculate all 5 of those, but you can see that using your calculator, you can put in the n values you want to calculate, put in the formula, and it calculates them all. It doesn't say the formula, but it calculates for all the n values you asked for. Okay, and that is the end.